Hello everyone and welcome to this lecture. We're going to talk about negative binomial and geometric random variable here. We will learn how to apply these probability distributions, negative binomial and geometric, and textbook reference for learning more about these two is section 3.6. So let's first recap what we discussed so far. We've talked about a uniform distribution as well as binomial distribution so far. And uniform distribution is for when you have equally likely outcomes in your random experiment. We learned about PMF, CDF, expected value, and variance of uniform. And for binomial, this random variable is representing number of successes in n Bernoulli trials. And I want you guys to read this statement a couple of times because in the next slide, once we start talking about negative binomial, I want you to be able to contrast between these two. So binomial is number of successes in n Bernoulli trials. And we also talked about PMF, CDF, expected value, and variance of this random variable. So now let's jump right into negative binomial random variable. The definition of negative binomial is number of Bernoulli trials until rth success. Okay, so let's go back to the previous slide. Binomial is number of successes in n Bernoulli trials. Basically, you have n Bernoulli trials, let's say, right? And the number of successes among them is binomial, but for negative binomial is the number of trials until rth success. So you continue your trials until you get to your rth success. And r is a parameter of this random variable. You can have r equal to 2. That means you stop counting these trials once you get to your second success. And the way that we notate this random variable is t sub r. Instead of n sub n that we had for binomial, here we have t sub r. Let's take an example like earthquake in a given day, right? And that's a success failure situation. You either have an earthquake in a day or no. So what is the difference between T5 and N5? N5 is binomial, T5 is negative binomial. We're following these definitions here. T5 is number of trials until rth success. So that would be number of days until fifth earthquake. But what about N5? N5 is number of successes in n Bernoulli trials. So that means number of earthquakes in 5 days. So you can here now contrast the difference between negative binomial and binomial. And the two parameters that negative binomial has is the r and the p. And p is the same p, is the probability of success. And this is how you define a negative binomial random variable. Another example is given here. T2 is the number of times we flip a coin until second head is obtained. Well, r is 2, p is 0.5, probability of success. So in contrast to T2, what is N2? Well, following the binomial definition, so number of successes in Bernoulli trials, that would be number of heads in 2 flips. So let's move on to the range of this random variable. Well, range of this random variable starts at r and it goes to infinity. This is very important. And in contrast to binomial, where the range starts at 0, here the range starts at r. Well, and it makes sense because negative binomial is number of trials until rth success. So at minimum, you would have to have r trials in order to have r successes. Let's take T5, number of days until fifth earthquake. Well, assuming that on a given day you can only have 5 earthquakes, then number of days until fifth earthquake cannot be less than 5. It can be 5, 6, 7, 8, all the way to infinity. So that's why the range of negative binomials starts at r. The PMF of negative binomial is here, and we'll apply that in an example in a second. And this is how it behaves, negative binomial distribution. You have it for 3 different random variables with different r and p. Well, let's take the first one where r is 5 and p is 0.1. Basically, the first one is T5, negative binomial with parameters 5 and 0.1. And that represents number of trials until fifth success, when the probability of success is 10%. And here you can see how it behaves. The peak of this distribution is about 40, right? Which means right around the 40th trial, you get to your fifth success, given the probability of success for this random variable. Now, let's take a look at this example. This one says, suppose that the probability that a bit transmitted through a digital transmission channel is received in error is 0.1. Assume that the transmissions are independent events and let the random variable x denote the number of bits transmitted until the fourth error. So a bit that is being transmitted is either an error or not. So you have these two outcomes in your random experiment, so that's an indication that you're dealing with binomial or negative binomial. And then here it defines random variable x for us, which is number of bits transmitted until the fourth error. Essentially, the number of trials until the rth error or rth success, right? So the random variable that we have here is T4. And probability of success is 10%. So let's just assume that we want to calculate probability of T4 equals to 10, right? So here 4 is the r and 10 is the little x in the formula here, x and r. Now, to calculate this probability, we follow the PMF formula for the negative binomial. So that will be equal to 9 choose 3, 0.1 to 4 times 0.926. That is equal to approximately 0.0044, which is a very small probability.